Welcome to today's deep dive. We are so glad you're here with us. Usually when we think about a medical diagnosis, there's this expectation of precision,
Well,
right?
absolutely, like engineering.
Yeah, exactly. Like you fall off your bike, you break your arm,
Yeah.
and the x-ray just shows that jagged white line on the bone. And the doctor points at it and it's just like, there it is. There's the fracture.
It's totally binary because we inherently crave that kind of mechanistic certainty, I think.
Right. We want reality to be visible and neatly categorized.
Yeah.
But the moment you step out of that hospital and into, well, human history or evolutionary biology, that x-ray machine just breaks.
It completely shatters.
Right. We look at the timeline of humanity for you and me, and instead of a clean line, it's just murky. We see wars and random mutations and economic crashes.
It just looks like a chaotic, localized sequence of accidents.
But, and this is our mission for you today, we are going to explore a radical, newly proposed theoretical framework from our sources called physical history.
And when we say radical, we mean this framework completely obliterates the idea that human history is random.
It takes the hard laws of physics.
Like quantum mechanics and thermodynamics.
Yeah, exactly, and complex systems theory. And it applies them directly to human evolution and recorded history. The proposition is that history is governed by strict, predictable, mathematical constants.
Which is a fundamental paradigm shift, because what the sources are proposing isn't just, a new way to categorize dates.
No, not at all.
It's a completely different foundational physics for understanding our origins. We are observing humanity as a physical system.
Right, governed by the exact same thermodynamic laws that dictate, like, the life cycle of stars or ocean currents.
And my goal today is to help synthesize this massive timeline presented in the research. We are going to track this from the formation of the Great Rift Valley millions of years ago, right up to the modern institutional friction of the British royal family.
Which is quite the jump, I know.
It is. But the objective is to unpack the underlying why behind the patterns of our existence, because when you stop looking at history as a humanities subject and start looking at it as applied physics, well, the mathematical patterns are just staggering.
So I want to tackle the biggest philosophical hurdle with this source material right out of the gate. Because if we were saying history is just physics, if human events follow an equation, what happens to human free will?
That is the big question, isn't it?
It has to be. Because if I wake up and decide, hey, I want oatmeal instead of eggs today, that's my conscious agency. How can a physicist possibly look at an equation and tell me that my history was on a predetermined track?
I mean, it feels like a direct affront to our entire conception of consciousness.
Totally.
It is the ultimate friction point when you try to merge hard physics with sociology. But the sources resolve this apparent paradox by leaning heavily into statistical mechanics and quantum probability.
Yeah, break that down for us.
Well, the framework absolutely does not claim your breakfast choice was predetermined. It posits that while individual microactions are entirely free, the macro system behaves predictably.
Right. The text uses that brilliant analogy with the gas molecules. Let's walk through that for the listener.
Yeah, that's a great example.
Because if I track one single gas molecule inside a sealed container, its movement is completely erratic, right? It bounces off walls, hits other molecules, changes direction entirely at random.
Exactly. Brownian motion. At the micro level, that single molecule possesses a sort of physical free will.
It's just chaotic.
It is. But the moment you scale up to trillions of interacting gas molecules, that chaos aggregates into absolute order. Those trillions of molecules suddenly obey the strict laws of thermodynamics.
So as an observer, you can calculate the exact pressure and temperature of the gas as a whole.
Even though you have absolutely no idea what any individual molecule is doing.
Wow. And I was trying to map that onto human behavior, and the text offers another parallel that really clicked for me. Think about global tourism.
Oh, right. The airline example.
Yeah. If you look at one specific person, you can never predict if they're going to wake up tomorrow, quit their job, and book a sudden flight to Tokyo.
Right. That is pure individual agency.
Exactly. But if you zoom out to a system of 8 billion people, airlines and hotel chains can predict the exact statistical distribution of tourists across the globe for any given month.
Down to the decimal. They don't need to know the individual's mind at all.
They just need to know the thermodynamic flow of the system.
And that is the crucial distinction here. On a micro level, you and I have absolute agency. We are the erratic gas molecules. But on a macro level, historical events distribute themselves probabilistically across space and time.
A system will always seek equilibrium.
Always. And what's profound about applying physics to history is how it treats the concept of time itself. Because in physics, past, present, and future are mathematically equivalent.
Right, the equations work perfectly in both directions.
Yeah, exactly. If you know the current state of a closed system, you can calculate forward to see where it's going, but you can also calculate backward to see exactly where it came from.
Which introduces this concept from the sources of past forecasting, or retrodiction.
Retrodiction, yes.
If we accept that history is a macro system, we don't just have to guess at our origins. We can take our current biological data, shoot a mathematical arrow backward through time, and basically forecast the past.
We can locate the exact moments when our systems underwent massive forced restructuring, what physics calls a phase transition.
Like water violently boiling into steam when it hits a specific energy threshold.
Exactly like that. Biological and social systems hit critical mass and undergo sudden phase transitions.
So if human history operates like a macro-physical equation,
Yeah.
what happens when we apply this mathematical ruler to the ultimate origin story?
You mean the forging of our biological hardware?
Yeah, exactly.
Well, to do that, the framework requires us to completely discard our traditional way of measuring time. We are so used to absolute time.
Like 1 AD, or the founding of Rome.
Right, we anchor ourselves to arbitrary human inventions. But absolute time doesn't exist in physics. There is no universe clock ticking in the background of the cosmos.
So time is entirely relative.
Precisely. To measure evolutionary time physically, the framework relies exclusively on relative distance, the intervals between major evolutionary nodes.
Kind of like measuring the physical distance between stars.
Yes, we are measuring the temporal distance between massive biological leaps.
And when the sources actually map these specific nodes of human physical evolution, they uncover a mathematical wave that honestly reads like science fiction.
But it's rooted right there in our fossil record.
We are looking at a specific geometric symmetry, right? A 1 to 2 to 1 ratio.
Based on a very specific foundational constant. That constant is 1,500 squared years.
Let's do the math on that. If you calculate 1,500 times 1,500, you get exactly 2,250,000 years.
2.25 million years. That block isn't just an arbitrary chunk of time. The sources identify it as the basic unit, the foundational heartbeat of our physical evolution.
I really want to break down this 1 to 2 to 1 symmetry for you, because reading how this maps onto our ancestry completely rewired how I view biology.
It's fascinating. Walk us through the nodes.
Okay, so the framework establishes node 0 at approximately 9.25 million years ago. This is the onset of what the sources call the waterside tree environment.
The geological crucible.
Exactly. And from node 0, we move to node 1, which is the emergence of the very first bipedal hominin, Sahelanthropus chidensis, roughly 7 million years ago.
So the interval between node 0 and node 1 is exactly 2.25 million years.
That is 1,500 squared times 1.
That is the first beat of the wave.
Yeah.
The biological system absorbs environmental energy for exactly 1 unit of this geometric timescale, and it produces the fundamental architectural base of our physical hardware.
The ability to stand upright against gravity. Then the wave expands. We move from node 1 to node 2. This covers the vast period from that initial bipedalism to the emergence of the Homo genus.
This is the era where we see radical brain expansion and the transition into constant habitual use of stone tools.
And this node locks in roughly 2.5 million years ago. So if you take the distance from 7 million years ago to 2.5 million years ago, the interval is exactly 4.5 million years.
Which is 1,500 squared times 2.
Exactly.
The second beat. The physics of the system dictate that it takes exactly twice as long, so 2 units of our base constant, to firmly lock in that skeletal structure.
To re-engineer the pelvis and free up the hands.
Yes, because once the hands are free to interact with the physical world through tools, it creates a feedback loop that forces the brain to expand.
And then we have the final release of the wave,
No.
node 2 to node 3, from the emergence of the tool-using Homo genus at 2.5 million years ago to the completion of anatomical Homo sapiens.
Meaning humans with a finalized modern skeleton. And crucially, a chin.
Which happens roughly 250,000 years ago. So the interval between node 2 and node 3 is, once again, exactly 2.25 million years.
1,500 squared times 1.
It's wild when you look at the architecture of that wave. 1 unit at a time, 2 units of time, 1 unit at a time. You are looking at perfect physical symmetry.
It marks the complete and total forging of the human biological vessel.
It just operates like a resonant wave, right? Absorbing kinetic energy, compounding it, and then releasing it to establish a new baseline of equilibrium.
It fundamentally challenges the traditional Darwinian view.
Right, the idea that we are just the product of random, chaotic mutations that happen to survive.
Instead, it frames evolution as a systematic accumulation and release of physical energy over strictly governed intervals.
It implies our physical form wasn't just a lucky biological lottery ticket. It was a physical system finding its optimal state of equilibrium against planetary pressures.
Yes. By the time the system hit that final node 250,000 years ago, the biological hardware of humanity was effectively complete.
But, math alone doesn't explain the mechanism. Like, an equation can elegantly describe the arc of a fallen apple, but gravity is the actual force pulling it down.
Right, the math is just the description.
So why did this specific 1,500 squared year cycle trigger in the first place? What was the massive environmental pressure that acted as the forge?
Well, to understand the physical mechanism, we have to look at how our ancestors managed to hack the ultimate thermodynamic penalty on Earth, which is gravity.
And this leads us to the environmental catalyst. According to the sources, the entire process is kick-started by plate tectonics.
Specifically, the formation of the Great Rift Valley in East Africa, roughly 10 million years ago.
This massive geological event tore the landscape apart, creating these immense trenches that filled with water, forming vast alkaline lakes.
And here is where the physical history framework directly challenges one of the most deeply entrenched narratives in anthropology.
Right, the traditional story, the one practically everyone learned in middle school biology. The savanna theory.
Right, the classic textbook image.
Our ancestors' forest habitat starts shrinking due to climate change. They're forced out of the trees and step out onto the dry, tall grass savanna. And to see predators over the grass, they are forced to stand up on 2 legs.
It paints a very vivid picture. But the physical history framework points out some catastrophic bugs in the savanna theory when you view it purely through the lens of thermodynamics and energy conservation.
Okay, let's look at human hairlessness, for example.
Yes, let's examine that. We are the only naked ape. It's a glaring biological anomaly.
The savanna theory argues we lost our body hair so we could sweat more efficiently, right? To cool down under the hot African sun while running or hunting.
But functionally, losing your body hair on a dry, open savanna is a metabolic catastrophe. Deserts and savannas experience massive temperature drops at night.
Oh, right. It gets freezing.
Without fur to trap a layer of radiant heat, a naked ape would literally freeze to death when the sun goes down. It's an evolutionary error. A physical system seeking survival would never optimize by creating a fatal thermal vulnerability.
Not to mention, human skin is incredibly delicate. Without fur, walking through tall savanna grass would result in constant lacerations.
Which leads to infection, yes.
So if the savanna theory fails the thermodynamic test, what is the alternative mechanism?
The sources propose the waterside tree hybrid environment. This model argues that hairlessness, combined with our uniquely thick layer of subcutaneous fat, are actually profound thermodynamic optimizations for a semi-aquatic environment.
When I read this part, I immediately thought of marine mammals. Whales, hippos, manatees, walruses.
The parallels are exact. If an organism is spending a significant portion of its day submerged in water, fur becomes a massive physical penalty.
Because it creates hydrodynamic drag.
And more importantly, when fur gets wet, the water displaces the trapped air. It loses all of its insulating properties and becomes incredibly heavy.
But subcutaneous fat is an internal insulator.
Exactly. It protects the core temperature whether the organism is wet or dry without adding external drag.
It's like the water was an evolutionary cheat code.
A cheat code, yeah, that's a good way to put it.
Because if we look at the biological baseline of our distant ancestors, they were the weakest apes in the environment. They didn't have the muscle mass of gorillas or the speed of gazelles or the fangs of big cats.
Right. When the Rift Valley formed these lakes, these weak ancestors were constantly being hunted by apex predators on dry land. Lions, leopards, saber-toothed cats.
So what does a physically inferior system do when faced with overwhelming kinetic force? It seeks a different physical medium where the predator's advantages are completely neutralized.
They fled into the shallow margins of the Rift Valley lakes because large feline predators are notoriously averse to water.
And once they were in the water, they discovered the ultimate physics hack, buoyancy.
Buoyancy effectively cancels out the penalty of gravity.
Right. If a quadruped tries to stand upright on dry land for extended periods, gravity just pulls down ruthlessly on their spine, their internal organs, and their knee joints. It's metabolically exhausting.
And physically damaging. But standing waist-deep in a lake, the water displaces your mass. It holds you up.
It allows a structurally weak ape to stand upright safely for hours on end while foraging for highly nutritious aquatic food, like shellfish.
Which happen to be packed with the exact omega fatty acids required for massive brain expansion.
And this creates a fascinating divergence in the evolutionary fossil record, right? A literal fork in the road of applied physics.
The sources highlight the divergence between our ancestors and the ancestors of chimpanzees and gorillas to illustrate this perfectly.
The knuckle-walking trap. I had never considered this before, but it makes complete sense.
It is a brilliant illustration of how environmental physics dictates bone architecture. The ancestors of modern chimps and gorillas also experienced this early, flooded Rift Valley environment.
But they retreated back into the deep, dry, heavy canopy forest too early.
Yes. They gave up the buoyancy cheat code and went back to standard gravity.
They returned to an environment governed entirely by heavy, unmitigated gravity.
But the evolutionary problem was that they still possessed these long arms and hands designed for hanging in the tree canopy, and now they had to navigate across solid ground.
It's a severe physical contradiction.
To handle the heavy gravity of land travel while keeping long arms for tree climbing, their skeletal system had to compromise. They developed knuckle walking.
They were forced to evolve locking mechanisms in their wrists and walk on the backs of their fingers just to support their massive upper body weight.
But human ancestors stayed in the water longer.
Exactly. By letting the buoyancy of the lakes support their vertical weight over millions of years, our ancestors completely bypassed the knuckle-walking trap.
Because the water mitigated the gravity, they never had to put their physical weight onto their hands.
And the sources back this up with hard fossil evidence. Specifically, the fossil known as Ardipithecus ramidus, or Ardi.
Ardi is the smoking gun for this theory. This fossil is roughly 4.4 million years old. A detailed analysis of its hand and wrist bones proves conclusively that our direct ancestors never possessed the heavy wrist-locking mechanisms required for knuckle walking.
We retained our long, delicate, straight fingers purely because we utilized the water as a buffer medium.
We avoided the heavy gravity penalty entirely.
So, to synthesize this phase for you listening, the water gave us bipedalism by canceling gravity. It gave us hairlessness and internal fat for aquatic thermodynamics, and it gave us our delicate hands by saving us from knuckle walking.
But the sources point out that this aquatic environment also provided the ultimate prerequisite for the single trait that makes us truly human.
The trait that eventually allowed us to conquer the planet, our voice.
Which transitions us into the final stage of our biological hardware completion. And it centers around an anatomical feature that is completely unique to us, yet so mundane we rarely think about it: the human chin.
The mental eminence. Because if you look at a chimpanzee skull, or even a robust Neanderthal skull, their lower jaw simply slopes backward from the teeth.
Right. They do not have a chin pointing out. Only Homo sapiens do.
It is a uniquely Homo sapiens structural feature, and the physical history framework connects this directly back to the aquatic environment and the biomechanics of speech.
To understand this, we have to look at the physics of how land mammals breathe.
Okay.
If you watch a dog running or a horse galloping, their respiratory cycle is physically locked to their locomotor stride. The impact of their front legs hitting the ground forcefully compresses their rib cage, acting like a mechanical piston for their lungs.
One stride equals one breath.
Exactly. It's an automatic hardware function. A cheetah doesn't have to consciously think about exhaling while sprinting. The physical act of running forces the breathing rhythm.
It is completely hardwired. But if your survival depends on escaping predators by fleeing into a lake and foraging for shellfish on the bottom of that lake, you have to be able to dive.
And diving requires a completely different physical capability. It requires voluntary breath control.
You need a manual override of the respiratory system. You have to consciously decide to hold your breath, submerge, and then consciously decide to exhale and inhale when you break the surface.
You have to decouple your breathing from your movement.
The sources argued that this voluntary breath control was the crucial pre-adaptation.
Millions of years of diving and wading in the Rift Valley lakes fundamentally rewired our ancestral nervous system, establishing conscious, granular control over our diaphragm, lungs, and eventually vocal cords.
But why does the chin matter in all of this? Like, how does a piece of protruding bone facilitate speech?
It's an issue of internal acoustics and spatial architecture. The chin, protruding outward, physically pulls the jawbone forward, creating a much wider spatial cavity behind the jaw.
Oh, I see.
This extra architectural space provides the necessary room and crucial muscle attachment points for the tongue to execute incredibly complex, rapid, precise movements without choking the airway.
So you combine the precise breath control we learned from diving to avoid predators with the microscopic tongue movements enabled by the internal cavity of the chin.
And you get speech. You gain the physical capacity to produce distinct consonants and vowels, rather than just analog grunts or screams.
You acquire the biological hardware required to transmit complex digital signals. You get words.
If you are listening to this right now, I want you to just pause and appreciate how profound that connection is.
Our ability to debate philosophy, to sing, to record this deep dive, to formulate a thought, all of it is a direct physical consequence of our distant ancestors holding their breath underwater to hide from leopards.
It is breathtaking, and I mean that literally.
It's the ultimate example of a physical environment forging a biological tool over deep time. But once that chin and those vocal cords were complete, roughly 250,000 years ago, our biological hardware hit a rigid limit.
We couldn't physically upgrade our bodies much more and still remain metabolically viable.
But hold on. If our hardware was so perfectly optimized 250,000 years ago, that creates a bit of a paradox, doesn't it? Why didn't we just continue evolving physically?
Right, like when the next ice age hit, why don't we just get bigger, faster, and stronger?
Why didn't we develop thick fur to survive the cold, like the Neanderthals did?
That paradox is exactly what the sources address with the concept of the hardware trap, and it's deeply rooted in thermodynamics.
Okay, lay it out for us.
Well, the Neanderthals are the perfect case study of a system hitting a physical limitation. When faced with the extreme, brutal cold of the European ice ages, the Neanderthal biological system tried to adapt by building a thicker, more robust physical frame.
Thicker bones, massive muscle density, a barrel chest designed to retain core heat.
They poured all their evolutionary energy into upgrading the hardware. But from a physics standpoint, this created an incredibly inefficient, brittle system.
To maintain that massive physical engine in a freezing environment, a Neanderthal required an enormous amount of fuel. Over 4,000 calories a day just to survive.
When the climate shifted even slightly, and the large megafauna they hunted became scarce, their entire system crashed.
They couldn't fuel the over-engineered hardware.
The metabolic overhead was just too high, and they went extinct.
They became a brittle system that shattered under pressure. But Homo sapiens took a completely different route. We didn't try to outmuscle the cold.
No, instead of waiting a million years for random genetic mutations to give us thick fur, we utilized our new software.
We used that chin and that breath control to formulate complex language.
This is the concept of emergence in complex systems theory. Emergence occurs when a system reaches a certain threshold of complexity and suddenly develops entirely new properties that couldn't be predicted just by analyzing its individual parts.
So we outsourced our physical evolution to our intellect and our community network.
Exactly. Instead of physically evolving to withstand the cold, a group of sapiens could use language to coordinate.
They could say, hey, let's work together to trap a mammoth, skin it, and use its fur to insulate our own bodies.
We didn't need to grow fur. We could just wear it. We didn't need stronger jaws. We could cook our food with fire, effectively pre-digesting it and saving massive amounts of metabolic energy.
This is the software revolution. The evolutionary battleground shifted entirely. Instead of rewriting DNA, which requires millions of years and countless generations, humanity began rewriting culture and language.
Which can adapt in a single afternoon. Information transmission became completely uncoupled from genetic replication.
And according to the math and the sources, this shift to software leads to a massive geometric compression of time.
If we go back to the original wave, the hardware took 1,500 squared years per beat, 2.25 million years to make a major leap.
But once we transitioned to software, the intervals between massive human shifts shrank violently.
The sources map this compression precisely. The evolutionary interval shrank from that massive 1,500 squared base down to 500 squared years.
Okay, let's do the math again. If we calculate 500 times 500, we get 250,000 years.
And that is the exact span of time from the completion of our hardware, the emergence of the chin, to the massive cognitive leap that resulted in the successful out-of-Africa migration.
The human network expanded across the globe.
And then the wave compressed again. The interval dropped down to 250 squared years.
250 times 250 is 62,500 years, and that maps perfectly to the time interval from the out of Africa cognitive leap to the dawn of agriculture and permanent human settlement.
The birth of actual civilization.
What you are seeing is an acceleration of phase transitions. The time required for a major systemic shift is being cut geometrically as the system's ability to process and share information accelerates.
Which means we must be hitting an asymptote.
Exactly. This isn't just an abstract history lesson. If the time intervals between these massive phase transitions are shrinking geometrically, it means we are approaching a wall.
According to the sources, humanity is currently standing precisely on the threshold of the next massive transition.
The framework identifies this upcoming threshold as the Z-point, culminating around the year 2026.
So if you're listening to this right now, driving to work or washing the dishes, what does this Z-point mean for our immediate reality?
Yeah, looking out our windows today, what did the physics say about us?
The source material provides a deeply neutral, physically based analysis of modern global society, and the diagnostic conclusion is pretty stark.
It suggests that collectively, modern humanity is currently operating with the exact same thermodynamic flaw that doomed the Neanderthals.
We are trapped in a primitive hardware mindset of materialism.
Even though we have this incredible global software network, we are still acting like we need to hoard 4,000 physical calories a day to survive.
Precisely. From a thermodynamic perspective, the current global structure, where massive amounts of wealth and physical resources are hoarded by a tiny fraction of nodes in our network, while vast numbers of other nodes experience starvation and poverty, well, it represents a highly inefficient high-entropy system.
It is a system characterized by immense internal friction and instability. We are fighting ourselves for resources that our technology could easily synthesize and distribute if our software, our societal structure, was optimized.
Which brings up a fascinating tangent in the text regarding the Fermi paradox.
The classic question, if the universe is infinite and 14 billion years old, why haven't advanced aliens visited us?
The physical history framework approaches the Fermi paradox not as a mystery, but as a thermodynamic certainty. It argues that any alien intelligence advanced enough to engineer interstellar travel must have, by necessity, mastered the physics of their own society.
You can't build a warp drive if your planet is constantly nuking itself over water rights.
Exactly. They have achieved low-entropy, highly stable, frictionless systems. They have evolved past the primitive hoarding of materialism.
So when a hyper-advanced, low-entropy intelligence looks at Earth, they don't see a pure civilization.
They see a barbaric, highly unstable system that takes its most concentrated form of energy, nuclear weapons, and points them directly at its own cities.
It's essentially the zoo hypothesis, or the great filter, viewed through thermodynamics. You wouldn't hand a loaded firearm to a wild animal that is currently in the process of tearing its own pack apart over a scrap of meat.
To survive and continue evolving, to cross this great filter without destroying ourselves, humanity must undergo another massive phase transition. The physical math demands it.
We have to cross the threshold out of materialistic hoarding. We have to guarantee baseline survival and energy distribution for all nodes in the system, meaning all humans.
And shift our entire evolutionary focus away from resource extraction and toward the evolution of intellect, data, and network stability.
Okay, I can accept that grand macro-level thesis. But if I try applying this directly to human timescales, I run into a bit of friction.
How so?
It's easy to look back millions of years and see patterns. But if human behavior is truly governed by these predictable laws of energy and entropy, do these mathematical wave patterns show up in modern recorded history? Not in the fossil record, but in the history books we read in high school.
They absolutely do. And this is where the physical history framework proves its scalability. The sources introduce a data set that tracks the universe along fractal scales based on powers of 81, or 81 to the power of n.
Why 81?
In the mathematical framework utilized by the sources, 81 is 3 to the 4th power. It acts as a fundamental geometric integer for structural tension.
When you scale this down to human lifetimes, the framework isolates the 81 to the power of 1 scale. That is an 81-year cycle.
According to the data, this 81-year wave acts as the resonant frequency that dictates the rise, the accumulation of internal friction, and the kinetic release or fall of modern nations and institutions.
Let's test that against the data provided in the sources, because this is where the physics maps onto our immediate reality. Let's look at the United States.
The sources point out this chillingly consistent 80 to 82-year heartbeat of American existential crises. Let's trace the nodes of the American system.
Okay, Node 1, 1781, the Battle of Yorktown. The British surrender, marking the effective end of the Revolutionary War and the true physical independence of the nation.
This is the birth of the system. The baseline equilibrium is established.
Now add exactly 80 years to 1781. You land on 1861, the outbreak of the American Civil War. The system literally tears itself apart in a massive, bloody release of kinetic energy.
The societal friction, driven by the fundamental contradiction of slavery within a system claiming liberty, built up over 80 years until the institutional framework could no longer contain the pressure.
It resulted in a near-total collapse of the internal network. Now take 1861 and add another 80 years. You hit 1941, Pearl Harbor.
The U.S. is dragged into World War II. The entire industrial and social fabric of the nation is forcefully reprogrammed to fight a global war, fundamentally transforming the U.S. from a fractured, isolationist republic into a global nuclear superpower.
1781, 1861, 1941. It's a terrifyingly consistent drumbeat of systemic crisis and violent phase transition.
And importantly, this isn't just an American phenomenon. If we look across the Atlantic at the European Union, the 81-year cycle is mathematically exact, though it manifests differently.
I tried applying this 81-year rule to Europe, expecting it to fall apart because Europe's history is so fractured and chaotic compared to the U.S. But when I looked at the Pan-Europa movement mentioned in the sources,
It perfectly aligns. The ideological origin of the modern European Union is a concept called Pan-Europa. It was first formally proposed in 1923, born out of the horrific trauma of World War I.
it was the genesis of the idea that Europe needed to unify its physical and economic systems to prevent endless cyclical war.
So 1923 is the conceptual birth. If I add 81 to 1923, I hit 2004. So we're looking for a kinetic release or a massive phase transition in the European system in 2004.
That was the year of the massive Eastern expansion, wasn't it?
Precisely. 2004 was the year of the EU's largest single expansion. 10 new countries, mostly from the former Soviet bloc in Eastern Europe, formally joined the Union.
It was the exact moment that the physical reunification of a continent long divided by the Cold War was mathematically and legally achieved.
Exactly 81 years from the ideological spark to the physical manifestation of a unified continental system. In this case, the release of energy was integration rather than destruction.
That is incredible. But let's look at something even more granular, something incredibly messy and human. The sources applied this exact same 81-year physical ruler to the British royal family.
Specifically, they track the intense, recurring friction caused by the second son or the spare in the monarchy.
And when you view a monarchy as a physical system, it makes sense. The system of monarchy is essentially a machine designed to funnel all gravity, wealth, and power straight down a single vertical line to the firstborn heir.
The second-born, the spare, is an anomaly in that physical system. They possess all the gravity of close proximity to the crown, but there is nowhere for their kinetic energy to go.
It creates immense friction. And the sources track a perfect 81-year cycle of this specific friction reaching critical mass.
The nodes here are deeply ingrained in British history. We start with the extreme constitutional crisis of King John in 1207.
King John was a younger brother, a spare, who took the throne after Richard the Lionheart, and acted with such tyranny that he nearly destroyed the entire system, leading directly to the Magna Carta.
Then the mathematical cycle jumps forward, hitting nodes of severe royal friction every few centuries. We see the War of the Roses erupting around 1450, heavily driven by the friction of rival royal branches fighting for dominance.
And the execution of King Charles I in 1612. Charles was a second son, entirely unprepared and unsuited to rule, which led to a catastrophic civil war and his own beheading.
The cycle continues relentlessly. 1774, the passage of the Royal Marriage Act. This was enacted specifically because the king's younger brothers were causing massive scandals and societal friction with secret marriages.
And then we hit the 20th century.
1936, the abdication crisis of King Edward VIII.
Edward VIII decides to abdicate the throne to marry an American divorcee. He simply walks away from the machine.
This thrusts his younger brother, the terrified, stuttering spare who would become George VI, onto the throne right as the machinery of World War II is starting up.
It was a massive historic shock to the British system. That was 1936.
And this raises the most compelling question of the data set. What happens when we add exactly 81 years to 1936?
Exactly 81 years after the abdication crisis of 1936, we hit the year 2017. 2017 is the year of the engagement of Prince Harry, the ultimate modern spare, to an American divorcee, which triggers his subsequent explosive exit from the royal family.
The system repeated the exact same pressure release, under almost the exact same narrative parameters, 81 years to the day.
These are not coincidences. When viewed through the lens of physical history, these events, whether it's the U.S. Civil War or royal family drama, are the physical expressions of system instability reaching a critical mass and releasing energy.
Think of a sand pile model in physics. You drop grains of sand one by one onto a table, it builds up into a cone. Eventually, the sides of the cone get too steep.
The friction can no longer hold the structure.
One single random grain of sand will trigger an avalanche, a collapse, returning the pile to a wider, stable angle. You can never predict exactly which individual grain of sand will cause the collapse. That's the free will element. But the physics of the sand pile guarantee that the collapse will happen at regular, mathematically predictable intervals of accumulated stress.
And that is exactly what we are seeing in the rise and fall of nations, the crises of ancient monarchies, and the very evolution of our own bodies. The math is always there, humming underneath the chaos.
We are thermodynamic systems, functioning within larger societal thermodynamic systems, functioning on a planet seeking equilibrium.
Let's take a breath and synthesize this incredible journey we've been on today. We started by looking at our weakest ancestors, millions of years ago, fleeing into the shallow lakes of the Great Rift Valley, using the physics of buoyancy to escape the heavy penalty of gravity, which allowed them to stand upright and keep their delicate hands.
We explored how the physical requirement of holding their breath underwater forged the neurological and physical hardware, specifically the internal cavity created by the chin, that would eventually allow the tongue to manipulate air into speech.
We tracked the massive time-compressing leap where humanity essentially hit a hardware limit, realized that physical upgrades were a thermodynamic trap, and transitioned entirely into the software of language, intellect, and culture to survive the ice ages.
And finally, we brought that mathematical ruler into the modern age, seeing how the 81 to the power of n cycles of energy release dictate the crises, the friction, and the phase transitions of our modern nations and institutions as we approach the Z point.
It fundamentally changes how you look at the evening news, doesn't it? But we want to leave you with a final thought to mull over, something that builds on everything we've discussed today regarding the intersection of physics and consciousness.
If our deep past is dictated by such perfect, cold mathematical symmetry, and if humanity is currently hitting the boundary of the Great Filter, that critical Z point where we must abandon our primitive materialism or risk destroying our own system under the weight of our own entropy, what role does your individual awareness play in tipping the scales?
Think back to our opening metaphor. You look at an X-ray of a broken arm, and it's a static image. The bone is broken, the physics have played out. But history, currently, isn't static. Are you just a single random gas molecule bouncing blindly around inside a rigid thermodynamic equation? Or can the conscious awareness of these very physical laws be the exact trigger, the necessary phase transition that allows our species to collectively rewrite the equation and survive?
In quantum mechanics, the act of observing a system fundamentally changes the behavior of that system. Knowledge of the equation might be the very thing that solves it.
Thank you so much for joining us on this deep dive into these incredible sources. We encourage you to look at the world around you, at the massive arc of history, and even at your own reflection in the mirror through this newly revealed physical lens. The math is everywhere. You just have to know how to measure it.